So let's just see the very first question under the sums based on distance formula. So the question number 1 says, do the points 3, 2, minus 2, minus 3, 2, 3, they form a triangle or not? And if so, name the type of triangle formed. So if they are forming a triangle, then we have to name the type of the triangle that is they are forming. So let us suppose if I am taking the triangle as of this form, and let us suppose if I'm taking the vertices of this particular triangle as nothing but A, B and C. Let us suppose if I am taking, because we just have to verify that whether the points they are forming a triangle or not. But for an instance, I'm taking a triangle and I am just taking its vertices as ABC, and I'm giving the coordinates to these vertices as nothing but 3, 2 and minus 2, minus 3, and further I'm giving this as 2, 3. So let us suppose if I am giving these vertices, the coordinates that are given to us, and let's just verify that whether they are forming the triangle or not. So let us suppose if I'm talking about finding out the distance, because first of all we'll find the distance of the points from each other. So let's just start finding the distance of AB first. So let us suppose if I'm finding the distance of AB first, so because of the distance formula, we do know that the distance formula is actually nothing but of the form square root of x2 minus x1 whole square plus of y2 minus of y1 whole square. This is nothing but the distance formula. So let us suppose if I am finding the distance AB, I am finding the distance AB and I am taking x1 y1 as nothing but 3, 2. It means I am taking x1 as 3 and y1 as 2, and further I am taking x2, y2 as nothing but minus 2, minus 3. It means x2 is minus 2 and y2 is minus 3. And y2 is minus 3. So I am finding out the distance AB first. So here we are looking for the distance AB. So further let's just start finding the distance AB. So the distance AB should be of the form using the distance formula. This would be x2 minus x1 whole square. So x2 is nothing but minus of 2 minus of 3 whole square plus y2 minus y1 means minus 3 minus 2 whole square. It means the distance AB is nothing but square root of minus 5 whole square plus of minus 5 whole square, which is nothing but square root of 25 plus of 25. This is 25 plus of 25, and further we can write it as nothing but square root of 50, and furthermore we can write it as 5 into 5, as we have 5 into 10, so we can write it as 5 into 5 into 2, and furthermore we can write it as 5 square root 2. It means the distance AB is actually nothing but 5 root 2. So let us suppose if I am writing it over here that the distance AB is coming out to be 5 root 2. Let's just talk about the further distances, that is BC and AC. So in the same way like we did for the distance AB, let's just talk about the distance AC. So let us suppose if I am taking the distance AC and I am considering the coordinates of A as x1 y1 and C's coordinates as nothing but x2 y2. I am taking this as x1 y1, this as x2 y2. So let's just find the distance. So x2 minus x1 means 2 minus 3 whole square plus y2 minus y1 means 3 minus 2 whole square. So let's just find AC distance, which is nothing but square root of minus 1 whole square plus of 1 whole square, which is nothing but square root of 2, because minus 1 whole square is 1, 1 plus 1 is nothing but 2. So AC is coming out to be root 2. So let us suppose if I am giving this as nothing but root 2, so this is coming out to be root 2. Let's just talk about further BC. What is BC? So let's just state BC as square root of x2 minus x1 whole square. So let us suppose if I am taking this as x1 y1 and I am taking this as x2 y2. So again further applying the same formula, that is x2 minus x1 whole square, we will get the value as 2. Again 2 minus minus of 2 whole square, because we have x2 is 2 and x1 has negative of 2. So this would be 2 minus minus 2 whole square. Again further plus 3 minus minus 3 whole square. So let's just solve it. So this is nothing but distance BC, which is equal to square root of 2 minus minus is plus. So 2 plus 2 is nothing but 4. So this is 4 square. Plus further we have 3 plus 3, that is 9. That is 6. So 3 plus 3 is 6 and 6 whole square is nothing but 36. So we have actually the value as nothing but square root of 16 plus of 36, which is nothing but coming out to be is equal to 6 into 6 plus 6 is nothing but 12. So this is coming out to be 3, 4 and 5, 52. So this is nothing but 52. So let's just take the elements common out of it or take the numbers common out of it. So let's just factorize 52. If we'll factorize 52, so this would be of the form 2 into 3 is 6, 2 into 2 is 4 and we have 2 into 6 is 12. So this is 2, 1 and 3. So this would be of the form 2 into 2 into 2 into 2 into root 2 into 2 into 13. So we can write it as nothing but 2 root 13. This is 2 root 13. Means the distance BC is nothing but 2 root 13. So this is 2 root 13. So let's just write it over here. We have this particular distance as nothing but, this distance is nothing but 2 root 13. This is nothing but 2 root 13. So hence we can see over here the distance AC is root 2, the distance AB is 5 root 2, the distance BC is nothing but 2 root 13. It means that it is actually not equal to each other. The distances are not coming equal to each other. So what we can further conclude about this triangle? So since we can see over here that if we'll take the sum of any two sides over here, so the distance of these two sides should be greater than the third side, so it definitely forms a triangle. So if I'll take 5 root 2, if I'll add 5 root 2 plus root 2, so this would be 6 root 2 and 6 root 2 is definitely greater than 2 root 13. And if I'll take the distance or the sum of the distance of any two distances, then it is definitely coming out to be greater than the third distance. So this condition always exist in case of a triangle, and hence we can say that this is actually forming a triangle. So let us suppose if I am writing the conclusion over here, since the sum of the distances of any two sides is greater than the third, so A, B, C are forming a triangle. They are forming a triangle. So this is the answer for the very first part. Let's just talk about if so, name the type of triangle formed. It says if it is a triangle, then you have to name that what kind of a triangle it is. So as you can see, we have the distance AB. So let us suppose if I am concluding the answer for the second part over here. So as we can see, we have the distance AB is nothing but 5 root 2. We have the distance AB as nothing but, the distance AB is nothing but 5 root 2. Furthermore, we have the distance AC. We have the distance AC as nothing but root 2. And further, we have the distance BC as nothing but 2 root 13. So if I'll take the squares of all the distances, means if I'll take AB square plus AC square, then it is definitely nothing but is equal to AB square means the square of this term. So this would be 25 into 2, which is nothing but 50, plus of AC square is nothing but 2. So this is actually coming out to be is equal to 52. And if I'll take the square of BC, so BC's whole square is nothing but 2 into 2 is 4, 4 into 13 is 52. So this is 52. So hence from this particular condition, what we can say that AB square plus AC square is equal to BC square, and this condition exists in a Pythagoras theorem. Means if hypotenuse square is equal to the perpendicular square plus base square, by the converse of Pythagoras theorem we can say that the angle A is nothing but is equal to 90 degree. The angle A is nothing but is equal to 90 degree, because the sum of this square plus this square is actually coming out to be this square. It means we have a perpendicular over here, and if it is a perpendicular, then definitely the triangle ABC, it means the triangle ABC is a right angled triangle. It is a right angled triangle, and we can say this by the converse of Pythagoras theorem, by the converse of Pythagoras, because we know that if hypotenuse square is equal to perpendicular square plus base square, then by the converse of Pythagoras theorem, the angle A would be is equal to 90 degree, and it definitely implies the triangle ABC. The triangle ABC is nothing but a right angled triangle. So triangle ABC is a right angled triangle. This is nothing but the name of this type of a triangle. So I hope the steps related to this particular question is all clear to you.